Okay, the first thing for this problem is to identify, like all problems, is to identify whether or not you need a free body diagram. It's not a dead giveaway because they do not ask for a force. Even in part 2, they want velocity and acceleration. So it's not a dead giveaway. So to determine whether or not you need a free body diagram, you count the degree of freedom. Block A or pulley A can move. It can go up and down in the slot. So that's one motion. So you count 1 so far. You prevent A from moving and you ask, can something move and not go limp or break? The answer is no. So the degree of freedom of this is 1. What that means is if you give the person 1 velocity, they can find any velocity. And if you give them 1 acceleration, they can find any acceleration. And you're given those. You're given a velocity and acceleration, 1 of each. And so you can find the velocity of the block and you can find the acceleration of the block without using a free body. So you don't need a free body. So this problem is relating one motion that is known to another motion. And the way you do that, the only way so far in the class, is to be able to use the length of a rope. Okay, so we know it's a length of rope problem, not a free body diagram. Okay, the first step you do to do a rope is to determine what's moving, and then you label a variable for it. Okay, so A is moving, and so we label a variable for the position of A. B is also moving, and so we find a measurement for that one. We have a variable for that. So we have 2 variables, SA and XB. Now, make sure that you don't treat SA as always equal to 4. It's not. It's going to change. You don't want to put 4 into your equation because your equation is going to be differentiated. You've got to keep it general until you finish all differentiation. Okay, so what I've got here is, circled here, is the length of the rope. So the rope is a length from here over to this pulley. That's a distance XB, right? So I have XB. Then I've got a little bit around the pulley, and that's constant, so I don't worry about it. And then I have the hypotenuse of this triangle right here. So the hypotenuse is equal to the square root of the 2 legs. One leg is 3. It's always 3, so I can put it in as 3. So it'll be 3 squared plus this side here, the vertical side, or the leg. So that would be times SA squared. So that's my equation for the length of rope. What you do after this is then you differentiate it to get the velocities. So you differentiate it. The length of rope is constant, so it becomes a 0. XB is XB dot, and then you take a derivative of this square root term, and you end up with this term right here. You have to use a chain rule, right? So you use a chain rule on the thing. You can check that you've done the chain rule properly. So this term has 1 dot. This term here that's underlined, this term, is all one term, and it has a dot term in it. So it looks like I've used my chain rule properly. Okay, so now what you want to do is plug in the things that you know. You know the velocity is 3, and it's going up. So if A is going up, SA is getting bigger. If SA is getting bigger, SA dot is a positive number. So you're going to put a positive 3 in here for the SA dot. SA, now that you've done your derivative, SA is equal to 4. And so you can put a 4 into here, as long as you don't plan to differentiate this again. So you put a 4 in here, plus 3 in there, 4 goes in here, and you can solve for XB dot. You'll find that XB dot is a negative number. A negative number means that XB is getting smaller because XB dot is positive, so XB dot is negative, so XB is getting smaller. If XB is getting smaller, the velocity of B is equal to XB dot to the right, right? To find the acceleration, what you need to do is you need to take the second derivative of this equation, and what you'll find is that you have terms of SA SA, SA dot, SA double dot, and XB double dot. I'm not going to take that derivative by hand. It's not impossible, it just takes time. So I'm going to do it with Mathematica, and I'll show you that in a second. Okay, I've pulled up Mathematica here, and what I've done is I've entered in the equation for the rope right here. So L is equal to XB in the bracket T right here. Bracket T tells Mathematica that the XB is a function of time, so it changes when time changes. So I just type in the equation so you can see that this is the equation for L that we have on the diagram. And so now I'm going to take the first derivative, I'm going to call it L dot, and then I take the second derivative, right? And so this is the first derivative, and it's equal to 0. So I'm making it an equation. So there's 2 equal signs there, and there's 2 equal signs there. So these are 2 equations. And if you notice, this is the derivative that we got when we did it by hand. This is the derivative I didn't want to do by hand, but Mathematica does it quite easily. So you have a first derivative and a second derivative. Since we're finished with all of our taking derivatives, it's possible to define what the SAs are now. So SA is 4. SA dot, that was given, that is the velocity. The velocity was going up, so SA is getting bigger. That's why it's a positive 3. SA is, or the double dot, the SA double dot, the acceleration of A, is also going up. So SA double dot is positive because it's getting bigger, so it's a positive 6. So I define the values of S. And then all I do is I say I want to solve these 2 equations, L dot and L double dot. So I say the answer is 1 equal sign is equal to the solve, and you have a set of equations. That's why you have a bracket, a curly brace there. Solve the first equation and the second equation for the 2 things that you want to find, XB dot and XB double dot. So you solve that. All this does here is say give it to me as a number rather than as a fraction. So XB dot is, this is the way when it solves it, right, is a negative 2.4. The negative tells you that XB dot is getting smaller. If you look at the picture, if XB dot is getting smaller, that means that B is moving to the right. So the answer for what is the velocity would be 2.4 to the right. Notice that XB double dot is also negative, so it's also getting smaller. So the acceleration is 5.4 to the right.